In this example, we want to use the idea of a geometric series to model a physics problem for us. So we have a basketball that's tossed straight up in the air, and you can see kind of a model for how this is. Of course, they're assuming the person throwing from the ground, which is not entirely accurate, but it falls to the floor. So it goes up and falls down to the floor. And every time it rebounds to 0.8 of its previous height. So it's going up and then going down, and then it reaches 0.8 times 20, which is 16, then 0.8 times 16, which is 12.8, and so on. So let h sub n be the height point after the nth bounce. So this would be h sub 0, this would be h sub 1, this would be h sub 2, and so on. With the initial height being h sub 0, which is 20 feet. Find the total vertical distance traveled by the ball. Now, if you're thinking, hey, the setup for this looks a little familiar, that's true. That's because we've already seen the setup in section 10.1. So we saw this, but we saw it as part of a sequence. So all we wanted to do at that point was come up with a formula for that height at that particular value. And we did right here. H sub n is equal to 20 times 0.8 to the n from n equals 0 to infinity. So now we're going to use that fact in here. So recall from section 10.1 that h sub n, my bracket got weird there, h sub n is equal to 20 times 0.8 to the n. This is the sequence from n equals 0 to infinity. You can see from that setup, hello A is 20, and hello R is 0.8, which notice it's less than 1, therefore it will converge. To A over 1 minus R, right? The formula will work out. Okay, so therefore I just need to come up with that formula. So let me just write that right here. Okay, so that means that my formula, which was from 0 to infinity of 20 times 0.8 to the n, would be equal to 20 over 1 minus, oh, I should have done that in orange, I'm sorry. Sorry, 20 over 1 minus 0.8. That would be 20 over 0.2, which is 100. Now think about what we just did. We found this 100, and you might be tempted to think, oh, that's the answer to the question. But it's not. Let me grab a pink marker here. So what we just did with this 100 right here, this 100, is we found the sum of the heights. So it's sort of like taking this bit, which was 20, plus this bit, which was 16. Here, let me write this. What we found was 20 plus 16 plus 12.8 plus 10.24 plus etc. Right? So, and we found that that was equal to 100. That's what we were doing. But that's only half of it. That's only the going up parts, right? So we figured out that from 0 to the height, 0 to the height, 0 to the height, right? So if we just add the heights, we will get 100. But that's not the question that they're asking. So it says find the total vertical distance traveled, right there. Well, that's not 100, because vertical distance traveled would be going up, but also coming back down, right? So since the ball goes up and down, the total vertical distance traveled will be 200 feet. Which was the question that they asked. So the geometric series finds vertical up, 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 height, right? It's adding all the heights. But that's not adding the height plus the distance back down, plus the height plus the distance back down. So to do that, you would double everything. So we'd make 100 times 2, which is 200. All right, now, just for a little bit of trick, suppose instead of saying it was thrown up from the floor, which is a little weird anyway. I mean, we don't often take a basketball from the floor all the way up. Suppose it was dropped from the 20 feet instead. So in other words, it went down and then back up and then down and then up and down and up and down and up and down and so on. Well, if that's the case, the total distance traveled would be the 200, but take away the part that we missed. So since we drop it from the initial height of 20, it would be 200 feet, take away that initial bit of 20 feet. That part right there, you take that away. So that would mean 180 feet.